Okay, guys. Now we're on to problem two. This is example one. All right, make sure you're looking at example one. Again, after you watch this video, you should go and you should do example two and then check the key to make sure that you get it right. Um, okay, so here's what we're going to start off with. We say Mark is riding his scooter. His position versus time graph is shown below. So here's the kind of gist of this thing, is that it's asking you to look at this position versus time graph. And then you need to be able to get a lot of information from that position versus time graph. So we reviewed this kind of stuff before, or we did this earlier, and let's kind of review what we should look at. So a really great idea is just to read the question. It says verbally describe, so I'm reading right here. Verbally describe Mark's position, time, motion, including the starting point, direction of motion, and information about velocity and acceleration. Now, on the last test, people missed this question because they didn't include everything the question asked for. So I really want you to pay attention here. Notice that there's 4 points possible, and it asks for 4 things. It asks for 1, the starting point, 2, the direction of motion, 3, information about the velocity, and 4, information about the acceleration. So what I'm going to recommend you guys do is do this. Since it asks for information about starting point, let's, and I'm going to do this. Let's see, does that work? Good. All right. So I'm going to do this. I'm going to say starting point. Okay, it wants information about that. It also wants position, information about direction. It also wants information about velocity. And finally, it wants information about acceleration. Okay, so notice what I've done here, guys. And I'm just gonna space this stuff out a little bit. Oh no. Come on down. Let me give myself just a little bit more space. There we go. Okay, so notice what I've done here. I've got those 4 things listed out, so as long as I'm putting information down for all 4 of those, I know I'm not going to miss a point for accidentally missing one of these things. So now I'm going to look over at the graph, and it asks me for starting point. Now notice that there's no numbers, all right? So I'm looking for numbers, and there's no numbers. So that means this is what's called a qualitative graph. There's not any numbers, but I can still get a lot of information. So you don't need to put down a starting point like 30 or 15 or something like that. Let's just say that the starting point is, it starts, well, I don't like to say that. Let's say it starts away from 0. So it's not starting, so really when I say starting point, it starts away from 0, it starts at 0. And let's say this too. It starts away from 0 in positive direction. There we go. Starts away from 0 in positive direction. Sorry about the handwriting. Okay, so I've got that marked off, starting point. Now, direction of motion. This one's pretty easy. Okay, we see that it's very clearly going back towards 0. It's going downhill. Okay, so when it asks for direction, I'm just going to say moving toward 0. There we go. All right, now things get a little bit trickier, okay? So it asks about velocity. So remember, there's 2 things I want to know about velocity. Is it positive or negative, and is it increasing or decreasing? So when I look at this, I want to be able to say, first off, I know that velocity is negative. I know it's negative because it's moving back towards 0. So again, anytime I'm downhill like this, that means negative velocity. Now we want to know, is it increasing or decreasing? Okay, so increasing or decreasing. Well, if I'm going to draw tangent lines, so let's do tangent lines in highlighter. So if I had a tangent line near the top, it'd be about like that. And if I had a tangent line later on, it'd be something like that. Okay, so notice that my tangent lines got less steep. Okay, so this tangent line is steep. All right, this tangent line is less steep. All right, so if I'm getting less steep, that means my velocity is decreasing. So velocity is negative, and then it's getting slower. All right, so, or we could say slowing down or something like that would be fine too, but velocity is negative and it's getting slower. So before we do anything for acceleration, let's go ahead. You can always rewind the YouTube video, by the way, if you need to go see that again, guys. Let's go ahead and draw our velocity versus time graph. So down here it says draw velocity versus time graph. And we just said some stuff about velocity right here, okay? So let's just go ahead and draw that in. Now it says be sure to include, let's notice this, guys, be sure to include units for V and T. So do we see how there's these empty spaces for units? We got to make sure we fill those in. So time. Time's going to be the same unit as it was up here. It was seconds up there, so it's going to be seconds down here. Seconds, good. Now velocity, we're measuring in meters up here, so that means velocity is always got to be distance per time, so it's going to be meters per second. Please don't forget those labels, guys. That's going to be a big thing that people miss, and I really don't want you to. Okay, so we know that velocity is negative. So I know that I got to be down here somewhere on the bottom side of the graph. Now the big question is, do I make it look like that, or do I make it look like that? So if we think about, we said that it's slowing down, it's getting slower. So remember that slower. So the slowest you can go is right down the middle because that's zero velocity, and zero velocity is just standing still. So, whoops. So if zero velocity is standing still, I want to get slower, which means I'm getting closer to that middle. So I have to start off here with some velocity and get closer to zero. So my velocity versus time. So see what I've done. I'm below the line, which accounts for that negative part, and getting slower means I'm getting closer to that axis. All right, so good. So look at that. Now I'm done with. I've got 2 points. Piece of cake. Now acceleration. Okay, so acceleration. There's a couple things we want to look at. All right. So first off, the first thing we can do. Okay, we know that acceleration is positive. Okay, the reason that acceleration is positive is if I look downhill, down here, this line is uphill. If it was downhill, it would be negative. So let me repeat. If you look down to your velocity graph, if it's uphill, it's positive. If it's downhill, then it's negative. But it's not downhill, it's uphill, so this is positive. Okay, so we've got our information for acceleration. Now, when I go down to acceleration versus time, first off, be sure to include units for A and T. All right, so T, just like before, is going to be seconds. A, now remember what we do for acceleration. We say meters per second squared. Okay, now the acceleration graph, this is the easiest one you got, okay? Because it's positive, that means this is above the axis. All right? It doesn't matter where you put it, just make sure that you put it above the axis. Okay? If this had said negative, so if acceleration was negative, then you would draw it below the axis, but it's not negative, so we don't put it below the axis. It's positive, so it's above the axis. All right, obviously in your test, you don't have to write all that stuff. That's just me helping you out. Okay, so that's what everything should look like. I've got all 4 points. I've got 1, 2, 3, 4 points there. I've labeled, and then I drew my line. I labeled, and I drew my line. So I'm all set, good to go. All right, now you go on to the second example and then check against the key.